Hey everyone, thanks for tuning in. This is the Composite Bicycle Frame Project. My name is Chris Key. I'll be presenting for our team of Wiley Kirks, Finley Marshall, Cesar Molina, and Elliot Bowie. We worked alongside our mentor and advisor for the project, Dr. Andrew Young. So we were tasked with developing a manufacturing methodology that allowed for the small scale manufacturing of carbon parts. And to do this, we designed, analyzed, fabricated, and tested a carbon fiber bike frame. So on to step one of that process, the design. We made a gravel bike as our final design. You can see it right here. It has really smooth contours and organic shapes, which not only looks good, but accommodates stress better in a material like carbon. So with that design finished, we could move on to the finite element model. This was essentially loading that design virtually and seeing how it would respond. To do that, we needed material properties, which was found by making 6 tensile test specimen with the same carbon layup that would be later used to make the bike. You can see the response right here. So with the material properties, we could fully develop the model, which was modeled after an ISO test standard of a falling mass test, which you can see right here. Once that loading was completed, we ran the analysis and we found factors of safety by comparing the maximum strain in each tube compared to the strain at failure of those dog bone test specimen. We also performed a buckling analysis where we isolated each tube and loaded them with the same values as that would be in the full frame. And we found factors of safety very high. We also found the bike stiffness, and we found that to be quite a bit higher than that of the physical frame that we tested later on. And we'll touch on the reasons why for that a little bit more after we talk about testing. So on to manufacturing. Now that we knew the frame was safe, we could actually make it. That started by cutting out a plug on a CNC router out of medium density fiberboard. This was essentially a model, a full-scale 3-dimensional model of what the frame would become. So the molds were then created around that plug in halves so we could later put the carbon in it. And those molds were cured in an oven at elevated temperatures to make sure they could withstand the temperatures the carbon would be cured at later. So once the molds are completed, we could start laying the carbon into the molds. You can see that right here. We needed to include a paste wax and a release film to make sure the carbon wouldn't stick to the molds. And then we added vacuum tubing along the hollow parts of the mold, which would allow the atmospheric pressure to essentially compact the carbon into the mold itself. This was kept on the mold throughout the curing process, that vacuum, and it was cured at 100 degrees Celsius for 7 hours. So once we made the final frame, which you can see right here, we wasted no time in testing it. We did impact and fatigue testing on the frame. Right here, you can see one of the fatigue tests where these pneumatic actuators would push on this dummy fork that we had inserted into the frame 100,000 times at 134 pounds each time. It took about 14 hours to run that test in total. So with the testing completed, we could go back and see if our assumptions were correct from the finite element model. As I mentioned before, the testing, the physical testing of the frame resulted in a quite a bit less stiff frame than the finite element model predicted. And that's likely because of deflection that would just naturally be introduced in this dummy fork right here, in how this actuator was mounted and in how the rear axle was mounted. In a finite element model, everything's perfectly rigid, so all of the force you get in is going straight to the frame. Here it's deflecting in some of the mounting points rather than the frame. So that's why we think the finite element model overestimated the stiffness of the bike. We pretty much expected that. So kind of in summary, we designed a bike, manufactured a bike, tested a bike, and then checked our assumptions of how that bike would respond to loading through that testing. So pretty complete story there. We're really proud of the result, and yeah, we just want to thank everyone for taking the time to watch the video, and have a good rest of your day.